we're going to do part 2 of 3.3 now, and this talks about the remainder theorem. So it's saying if the polynomial f of x is divided by x minus c, then the remainder is f of c. So you can see that those are repeated. So given this function, use the remainder theorem to find f of 2. So we're saying that f of 2 is our f of c, meaning that that should be the remainder when we're talking about x minus c, which in this case, the c is going to be the 2. So the 2's are going to be in place of the c values. So we're going to divide by x minus 2, bring down the 1, and those numbers came from here, 1, -4, 5, and 3. 2 times 1 is 2, add those to get -2. Multiply these two to get -4, add those to get 1, multiply 2 times, jumped one here, 2 times 1 is 2, so 3 plus 2 is 5. So this remainder 5, we should also get if we take f of 2. So I'm going to go in and put 2's in for all of these x's. So 2 to the third is 8, minus 4 times 2 squared is minus 16, plus 5 times 2 is 10, plus 3, and you get the 5. So we just proved that f of 2 is 5. And that means that when you divide by x minus 2, you're going to get a remainder of 5. Okay, let's go ahead and practice that again. So this time we have find f of -4. So that means that we're going to be using x minus -4 as our divisor. And we're going to see what we get for our remainder. So I'll bring down these numbers for synthetic division. Bring down the 3. -4 times 3 is -12. That gives us -8. -4 times -8 is 32. That gives us 27. -4 times 27 is -105. Or -108, which gives us -105 as our remainder. So by the theorem, we're saying that if we take f of -4 here, we should get -105. So I'm going to replace my x's with -4 in the original. That gives us 3 times -64 plus 4 times 16 plus 20 plus 3 gives me -192 plus 64 plus 20 plus 3, which gives me -105. Okay, so just thinking back to that theorem, it said x minus c, the remainder is whatever f of the same c is. So in this case, we're doing x minus -4. So the remainder is f of -4, which is -105. Next, we'll talk about the factor theorem. So f of x is a polynomial. If f of c equals 0, then that means x minus c is a factor of f of x, because we're saying that there's no remainder. If x minus c is a factor of f of x, then f of c equals 0. Okay, so we're going to solve this, set it equal to 0, given that 3 is a 0 of the equation. So this means that f of 3 is 0. Because f of 3 is 0, the factor theorem tells us that x minus 3 is a factor of f of x. We'll use synthetic division to divide f of x by our x minus 3. So we're going to be dividing by the minus 3, or just positive 3, sorry, because it had to be in the x minus c form. And what we were dividing was 2x to the third minus 3x squared minus 11x plus 6. So I'll bring my 2, negative 3, negative 11, and 6 down. Bring my 2 down. 3 times 2 is 6. Gives me 3. 3 times 3 is 9. That gives me negative 2. 3 times negative 2 is negative 6. Remainder of 0. So what this means, if we write this out, that would be 2. Then we have to take 1 less than this. It would be x squared plus 3x minus 2. So that means 2x squared plus 3x minus 2 is a factor of our original since there was no remainder. Therefore, we can, let me draw the arrow here, we can rewrite this as x minus 3 was one of the factors that we divided by, and then 2x squared plus 3x minus 2 is another factor. So we just rewrote this into a little bit of a factored form. We can actually factor it down even farther than that. And now we can actually finish this out and figure out what are the other zeros. So x minus 3 is one of the zeros we said, and that's because if you add 3 over, that is one of the x values that would make this equal 0. So now let me try the other one. We already did this one, so now I'll do this one. Okay, so we need to factor this trinomial down. You could use quadratic formula, but I know this one factors well, so if I multiply these two, I get negative 4. So I need to find factors of negative 4 that add up to positive 3. So I'm going to use 4 and negative 1, because that would add to positive 3. So I'm just going to split this into a 4x minus 1x. That's the same as 3x. Bring down my 2x squared and my minus 2. Then I can group these, factor out a 2x. That leaves me with x plus 2. Factor out a negative 1 here. That leaves me with x plus 2. So now I have 2x minus 1 times x plus 2 as my factored form of that whole thing. So then I can go ahead and solve that. I'd have 2x minus 1 equals 0, or x plus 2 equals 0. Go ahead and finish. 2x equals 1 divided by 2. X equals 1/2 minus 2. X equals negative 2. So the solutions or zeros are, we'll write them in order, negative 2, 1/2, and 3. So those are all the x's. They would make this function equal 0. So these are some conclusions we can make. If f of x is divided by x minus c and the remainder is 0, then that means c is a 0 of f. It would make the equation equal 0. And c is a root of the polynomial equation. If f of x is divided by x minus c and the remainder is 0, another thing we can conclude is that x minus c is going to be a factor of the original function. And I did put up one more example. You can walk through it step by step on your own in your notes. There are 3 different slides on that example, so I would encourage you to print them off. And you end up getting this as the solution. So I would practice it and then see if you can get the same answer as this example.